been with UBS for almost 4 years now, and have been fortunate to be working on this new concept, which many of you might have heard of, but just want to share our experiences. By no means is the journey complete, so I'm not standing here to tell you how we have conquered the mesh challenge and how we have built this great ecosystem. We have not. And if there's anybody in this room who has solved it, then please talk to me after the session, because we definitely haven't solved this. Is there anybody here who's not heard of data mesh? Okay, so very few people, but most of you have. So mesh sort of follows, I mean, you might think it's the flavor of the season or the year. You know, we had data warehouses, we had lakes, you know, both of these have run. Data warehouses have been around for a long, long time now. And then we had lakes on commodity hardware. They've all had their problems, and as we move to the cloud, and I'll show some of the problems we have been facing in UBS, as we move to the cloud, they are creaking, and we know what these problems are. So Zimag Degani, when she was part of ThoughtWorks, came up with this concept. It's probably about 3.5 years now. It was called, or termed, a new paradigm. And there were 4 key principles. I'm not going to describe mesh. You can read it up. It's a wonderful book to read. But the 4 key principles that form part of the mesh, one is the concept of domain ownership. You might all have heard these phrases in the last 3 days, right? Various presenters have spoken about this in different contexts. The mesh tries to bring this together. So the first concept is domain ownership, i.e., data products or data in general is owned by the people who produce it. Data as a product which follows on from them. Effectively, you package data and sell it like you would sell products on Amazon, right? Why shouldn't it be presented as a product? So it's not so much techie. Traditionally, data is treated as something that technical people have to do, and the business people just give you written requirements. So it moves from there where consumers or i.e. business can directly go and consume it themselves. Self-serve data platform, I'll talk about that a little more, but this is all around the tooling that must be provided to build these products. And finally, governance. Governance is super critical. So this is also part of the core principles of the mesh. But I'll just take a step back to a story, right? This is a story. We've probably many of us are familiar with this. So if you sort of go back to the 60s, even before I was born, we had the Boeing 707 DC-8. So this was the age of the turbojets, right? Single aisle aircraft, but people were very excited. You could fly across continents in a few hours and not days and weeks, as used to be the case before. These aircraft didn't crash and burn ever so often, so it was safe. But as the as the passengers kept increasing, it was expensive, and airports couldn't handle the additional load. So there was a challenge. You know, what do we need? What do we need to do to make travel cheaper, easier, and more accessible? Right? Very similar problems to what we face with data today. Then came Boeing 747. 67 or 68, I think, is when the first aircraft was produced. I was fortunate because my brother-in-law used to work in Boeing, and he was part of the first 747 program. So he fondly remembers this. And he had a tear in his eye when British Airways had the last flight of 747 a few years ago. But it just didn't happen by accident. Right? There were a number of things that came together for this aircraft to be formed. So that little picture that you see in the middle, that team was called the Incredibles, apparently. So they were the people, or designers and builders, who were involved in the very first program. So some of the things that came together, you know, for this aircraft to be built, first of all, you know, 4 engines were there before, but this was twin aisle, so it was huge, and you had that distinctive nose and, you know, the floor on the top. So one was wide body design. I'll just cover 1 or 2 things here which are important to call out. One was the thing around engines, right? Engines became a lot more powerful, which means it could carry huge loads. And then even today, I'm amazed that A380, I mean, all of us have probably flown A380s, amazing aircraft. I can't believe that it weighs 540 plus tons at takeoff. It's an amazing feat of engineering. And all because of engines and wing flaps. As small as they might seem, wing flaps have played a very key role. And then finally, use of fault tree analysis. We might all think this is fancy engineering and metal fabrication and so on, but even things like fault tree analysis have helped make flying safer. So it's very similar now. So if we come to UBS, I mean, what we have been doing, we have highly valuable data. Every organization has highly valuable data. Within one area, the division that I work in, investment banking, we have close to 160 petabytes of data on-prem, largely on-prem. We are moving to the cloud. But we do get a lot of value out of it. We use it internally, not just for risks and reporting and stuff like that, but also to derive value. We sell data to our clients, we package it up, but it's becoming harder. We are also actively moving to the AI/ML age, and it's harder. So we have lots of data, but it is siloed. Again, something that must be familiar to a number of you. Financial institutions have this problem, especially those of us who come from an on-prem estate. We have tried to solve the problem by joining it up. We extensively publish data, but it's not good enough. I mean, you have this feeling, producers have this feeling of fire and forget. So why are you coming and asking me for my data? I've just published it, go consume it, right? And it's over there. And then we spend 3 to 6 months trying to get access to it. I don't know what data it has. I have to ask people, etc. So that's the third problem, hard to access. So what if we were trying to pivot? So I think there was this realization that if we move to the cloud, it's going to be hard. We can't lift and shift applications. Even though we have microservices and all these fancy cloud technologies, auto scaling, multimodal databases and so on, we couldn't possibly imagine having 160 petabytes of data on the cloud because the cost would be astronomical. So even within the company, we have stopped saying cloud is a cost play. It's not a cost play. It might be an efficiency play, and we have heard many speakers talk about this in the previous sessions. It might be an efficiency play, but there is hard work to be done. And we felt mesh is something good. Mesh will help us if we do it the right way. So democratization. So it's not so much about just building data once and so on, but we really need to democratize, make data freely available. We have some internal challenges. There are problems that have been posed for us to solve. Cloud adoption. I mean, a lot of things that we will see really can be done on the cloud. And then we have some modern architecture standards that our CTO has published. So we call them digital principles that we have to adhere to. So I think we felt that the mesh in combination with using the tools that cloud providers have will help us achieve this. I'll now start with some conundrums, right? And this reflects the problems we have had. We still have these. Like I said at the start, we haven't solved this problem. We still have these. One is the producer conundrum. And I do this. I mean, it was my day job till very recently when I was heading data architecture. I talk to the various streams. We are agile. We are organized along agile principles. It's good. We do produce software in agile, and it's very quick. But when it comes to data, producers don't know what the right data is. As I was saying, producers publish data. They don't know who consumes it. They have a fair idea who does it because those people come with problems, but otherwise there is no register of who is consuming what. It's very hard to know. Models, producers by default use their internal models. Most of them are relational because we come from the Oracle SQL Server world. So we have got extensive physical models, unfortunately not documented well, but we publish, we'll just publish it. So if somebody comes along and asks for data, we just publish it in our internal physical model, and then you say, go figure. Data products in a consistent fashion. This came up in the sort of train line session. We take I don't know whether I should say we take pride in this, but in many ways, I think we use probably every technology known to mankind, especially in databases. We use every possible flavor of database. And that's hard because the consumers have to know how to interact with that database. So producers would like a consistent way. They like to be told how to do it. It just makes life easy. And then how do I then publish my products in a way that people can understand it? So these are some of the conundrums that producers, so when we go and ask people to produce data products, it's easy to say produce products, but how do you do it? These are some of the questions that we get asked. If you flip it on the consumption side, very similar, right? Consumers look for data, they don't know where to find it. Most often they start with data that they have been consuming for many, many years. And believe it or not, the conversation is around the files that are transferred. They're largely batch. So we have these very long-winded conversations when you ask, what data do you need? They say, but I can only tell you what data we consume. Show us what data you consume. It's not electronic, no digital, nothing. It's an email with 100, 200 pages worth of attributes with file names. So you can imagine most of the people who produce the data are no longer in the company because this goes back 15, 20 years. So you have to sit and trawl through all of this. And again, surprise, those attributes are physical attributes. So you then have to go and look at what it means in the database. So these are the kinds of conversations we have. So data model is very important. Consumers want to understand data models more easily, and I'll talk a little bit more about it. Data quality. We have some instances where data quality is managed entirely by the consumption teams, simply because they may face off to the regulators or it's used for balance sheet purposes or something like that. But this is handled much further down, which means we may not get it right, or in the worst case, we keep doing the same thing multiple times because the producer could have done it once, consumers do it multiple times. Finally, the governance conundrum. In one word, most of this is done manually today. Right? We have systems, but there are people updating things in the system. One good example is master and authoritative sources. All financial institutions have to adhere to a number of regulatory standards which say data has to be consumed from master and authoritative sources. And we have design authorities which review this and then maintain this manually in a system, right? Things like that. So our goals, when we started the data mesh initiative, we were calling it by other terms. We used the term ADA, for example, for a while, and that's changed. But this hasn't changed. So our goals have always been better governance. So we want governance teams to look at data, metadata, the way it is presented, and without having to ask people. So data governance, management, technical simplicity, I spoke about the producer conundrum, and then improved business efficiency. This is from a consumption angle. So this has always been our goal. We have been doing it in various ways on-prem, but they have been, with suboptimal results, but we want to do it properly on the cloud now. I'll just switch. This is one slide I've thrown in just to show the kind of data products that we want to build. Again, this is standard. Zemak talks about it in her book as well. So the source-aligned products that you see at the bottom are what? So we expect hundreds of them, if not thousands, but definitely hundreds. If it goes into the thousands, we probably have duplicates, but we expect hundreds of these. So the idea is everywhere that the data is actually produced, mastered, and we have a very complex environment. Right? Investment banking is huge, complex, spans multiple asset classes, and UBS being global, we span across multiple countries. So we would see a number of instances of these source products. So wouldn't it be nice if this is all registered? You have an Amazon of this. A good example of this is Hugging Face, which I look at. So you could see all of this in one place with a common model. So that's one. People who produce this may not necessarily know or will have no idea how exactly it's getting used. But if they could produce this data in a consistent way, we then have the aggregators and the consumer-aligned teams coming in. So these could be the AI/ML teams, reg reporting teams, financing teams, whoever. These are the people who consume this source aligned data, and you can see some examples of this. And maybe there'll be someone interested in the consumer products. I mean, you could call this bronze, silver, gold in warehouse terminology, very similar, but this is the concept. So if you look at the architecture, and I'll talk about the problems we have faced when we try to do this as well. So this is what we believe are the key components of the mesh. So we have the data product right there in the middle. That's our objective. That's what we want to build. This could be anything. It could be data sat in a relational table. It could be NoSQL. It could be a JSON message on a Kafka topic. Anything can be talked. There's the concept of a distribution. So you can distribute data products in any fashion. It could be real time. It could be batch. Anything. But to build that data product, you have to have a number of things that are required. Remember the Boeing 747 analogy. So you need a number of other tools and technologies involved. So we've got the taxonomy. I spoke about the model. So the question is, how do I describe my data model? I need a taxonomy. So in our industry, for example, in financing, investment banking, we've got something called common domain model, the ISTA model. Every sector, healthcare, automobile, everybody has some form of a common domain model. The question is, can we adopt it? Can we enhance it where there are gaps? It's hard work, but a taxonomy definitely helps. There will always be internal models, right? We always customize products, so yes, we need that. We need some mechanism of registering this data product. It has to be in a registry. Should we build a registry internally? Is there something available out there in open source, vendor product? We'll look at it, but registration is a key part. And the principle is you cannot consume any data that is not registered. Right? There's no concept of just connecting to your friend's data sat there in some database under his desk, not allowed. So registration becomes important. So the challenge is, how do we make this as easy as possible, as simple as possible? Then we have got lineage related to governance. And then as you go down the chain, you've got the tools that are required to monitor and consume this. So you've got the marketplace. I've thrown in some industry standards, which I'll refer to later. But these are the standards. Some of them are mature, some are still maturing. And these, we believe, is what we will need to build the mesh ecosystem. This is just one view of the stack. I won't go through every box, but some of these will be familiar. We have used this even in the warehouse days. We've got ingestion pipelines, we've got data management, we've got these tools. But those tools tended to be very use case specific, division specific. We use that in a certain way in an Oracle infrastructure based or real time streaming architecture. So they tend to be different. But if you look at it again, bottom to top, when I showed you the three types of data products, you got the source, that's the foundation layer. We expect all producers to produce data in the same fashion in a consistent way. Then we have got platform service, and this is where we have been facing most challenges. I'll talk about that shortly, and we haven't solved it. And then on the top are the nice sexy bits, analytics, AI, ML, Gen AI, all these things that we keep talking about. And how do we do it today? We probably take a copy of it. But this is what we want to try. So the holy grail of data mesh is access in place. Wouldn't it be great? Doesn't matter whether I want to produce a Power BI report, an ML model that's doing some recommendation, driving a recommendation engine for clients, but they both access data in place. That's what we are aspiring here. The one difference to what Zdeněk had originally said, I think it's evolving now, was data mesh was built more for the analytical space, right? So you would all have heard, we've heard a lot about microservices the last 3 days. So the idea was in the operational world, the problems of the operational world have already been solved because you've got microservices, right? But analytics is still a problem waiting to be solved. So we just spoke about warehouses and lakes. But the way we have been looking at it is, if we could solve this, I spoke about distributions. If we could solve this both from a batch and real-time perspective, if you could provide both data at rest and in motion, then what else would an operational consumer need? So that problem is solved, right? So that's what we are trying to do now. So this has been this is what I'm now going to talk about is the journey we have had over the last 18 months. Some of the people involved in this journey with me are actually here as well. So this is the idyllic skyline, right? So we want to build a grand city, right? Imagine Milton Keynes, we are just about to build it all over again. What would that city look like? Before anyone comes to live there, we need roads, we need water lines, electricity grid, probably a train line, tram, whatever. We need all of these to be in place. We then have to build schools, hospitals, so there's some buildings that we will start having. But this is all ahead of the people coming and living there. So what we are trying to do is in the mesh is we are building these common things, data platforms, for example. It could also be standards, tooling, etc., etc. We then want the producers to come in and start using them to build things. Right? So you can imagine you are building all these factories, and the factories produce goods. And then they don't have to be shipped off somewhere to another country or a continent. We have consumers who come and consume it from there. So this becomes a sort of self-sustaining city. So this is how it looks like, wonderfully. But where are we today? It's not a set menu, it's a la carte. We get into a restaurant and we say, could you show me what your vegan menu looks like or something? And they give me a menu with 15 pages, and then I have to go through it and choose the 4 items that are of interest to me. Looks great because anybody who goes into that restaurant probably has got something they can eat. Right? They will never walk out without eating anything. But you can imagine how difficult it is if everybody has to do this. So in our world, if you want to go and build something on the cloud, and we saw some of that in these 3 days, we have got wonderful products, tooling, we have got vendors, we have got open source tools available, but we have to choose, every team has to choose the tech stack for every single use case. We can produce standards, we have already done a lot of it, but we still struggle. So this is where we have. So what we would like is set menus, options 1, 2, 3, which covers 80%. You just choose, you ask a set of questions, and then you get the answer. And then you always have the 20%, of course, which is the exception. So what are the things that have gone well for us? Fortunately, we have built the registry. That's the key part. And as we go along, I'll try and talk about some of the open standards. We have built some custom tools, which I can't talk much about, but some of the open standards, the W3C standard, for example, is very good. There are 2 or 3 standards they have produced, one called DCAT, which you can look up. This is an excellent standard that underpins a lot of the registry, and many of the open source registry tools that are out there use DCAT. So we have extended this, but this is good. What we have also done is, this has been successful because we have spent the best part of 2 years building it. We couldn't find one tool in the market that could integrate into SDLC. So we had steps where producers could not publish their data without the metadata being captured. You might think this is a very small step, but traditionally IT teams build, publish data, it's gone. And then when you go around trying to find out the metadata, it's manually maintained, it's out of sync, no guarantee that it reflects what's in production. So we've integrated that into SDLC, so you can't publish anything without it being registered. It forms part of the standard governance process, which means it cannot be deployed into a higher environment without somebody from the data management office reviewing it, checking the mappings, and approving it. So that's the level of integration we have done. So we have had to do this. So we have used some open tools, standards, and then built an application around it. So this is all hard graft. It takes time to do. Data quality. We are not there yet. There are again a lot of data quality tools, but these work within the boundaries of the vendor solution, or even where it is open source, it works in a certain portion. So it might work well for batch, but not quite well for real time. Things like that. Again, 2 good standards. One is called DQV, which is the data quality vocabulary, Again, I was talking about taxonomy. The way we describe data quality rules differs. So if I speak to 3 of you here, we would probably have 3 or 4 different ways in which we describe data quality. So this helps us to standardize that. And DMN is decision model notation. It's an OMG standard. It forms part of the BPMN suite, business process modeling standards. This is particularly good because it allows you standardize the taxonomy, and then you can write these rules in a machine readable form. It's an XML. Under the covers, it's just an XML payload, but you have a UI which business people can use. So you can write rules in the form of tables, expressions, etc. So these are the 2 tools that we are using. Again, we are having to do some build internally, but there are open source tools. DMN is one. You have the entire Cogito Quarkus framework which can be used to build these rules. So we are going to be using these open source tools ourselves. Again, needs to be integrated into governance, which is a solution we don't have. Right? So we want rules to be defined, attached to data products, approved, etc. So again, you can imagine this is a circle, virtuous circle. Everything we do has to be part of this circle. Developer tooling is probably where we are most behind. Right? Cloud is great. You got lots of solutions. Any problem you have, there is probably a solution that fits your bill, but doesn't work well with someone else's solution. So Backstage we have looked at. We had a presentation of Backstage here, plugins. So that's a tool, that's an open source tool that we are looking at to simplify the way producers build it. So the consistency that I was talking of before, we want to achieve by the use of Backstage. This is early days, so maybe I'll have a chance to come back here next year and give you a demo of what we have been doing, but this is this. There are some tools that have been made available via Finos, the open source foundation. So you got Legend, for example, but we are trying to build something ourselves here. And again, the idea for us is model-driven development. I am particularly passionate about this because if you start with the model, then it just makes products that much more easier to understand. Access is probably the most difficult area. We, by no stretch of imagination, have we solved it. So we still have silos, even on the cloud, I have to frankly admit, because we have been talking very closely with vendors. It's extremely hard because our data spans geographies. You know, you can't see Swiss data outside Switzerland. You can't see Chinese data outside China. Somebody in China moves out of the country, can't access the data. I mean, we have got every possible combination of access control rules, info barriers, etc. Wealth data has to be masked, and there's no easy way of doing it on the cloud. So again, like I said, if anybody has solved this problem, please talk to us because we haven't solved this. So fine-grained access control. So blob stores, for example, don't support row and column level access control. You can use something on top. I mean, Databricks, for example, supports it. But then how does it coexist with other persistent stores? How do we get NoSQL databases to operate in this, interoperate in this? And then finally, how do we get analytics and operational consumers both going through the same access control framework? So we are looking at, I mean, ODRL is not a machine readable language, but that's something that the industry is trying to push. So we are saying you publish data product, it only solves one part of the problem. But where the industry is moving to now is to say we publish products, and here is a license file that goes along with it. The license file is machine readable. So London Stock Exchange is a good example. They publish thousands and thousands of data sets every day, licensed, and they are looking to see if the consumers can implement ODRL, whereby you don't need people and documents to be exchanged. The ODRL effectively implements the contract. But we need all of the other things I mentioned to be available inside the organization for this to work. Security is, I mean, I just spoke about many of these things, but here we are looking at open policy agent. We don't have an implementation of this yet, but this is something we have been looking. So all of the policies I was mentioning before, we want to be able to define and attach it to the data product. Again, we don't want this to be done by every consumer. Can you imagine you got hundreds and thousands of data sets, you want to access it, and then every time you find something interesting, you can't see what's inside of it. The only way you can see it is by asking someone permission. So that goes through a process, a workflow. You get approval, you access it, and then realize it's actually of no use to you, and then your cycle repeats. Right? So what we want to do is attach it to the data product. You can go see what's in it, you can see sample data. If you're allowed to use it, that's it. You don't have any request, you just go use it. But if it's some restricted data, then you ask for access. Lineage, difficult area. We have solved parts of it. Again, lineage, there are tools out there. I mean, Azure has, we use Azure extensively. But the challenges are, it again works real time. It might show you data lineage for a certain kind of technology, say Java, but then won't show you for Spark. It doesn't show you business logic. So front to back, it's hard to see what the business logic is. So we have had to implement metadata capture utilities that will then push this into the lineage tool, using Atlas API. So there are some standards. Atlas is a good standard, but the challenge remains as to, with all of these different tools and technologies available on the cloud, how do you use it? Traditionally, on-prem, we were using a tool like Informatica. Where we were using ETL-based tools, it's fairly straightforward. Use Informatica, great rich tool. It gives you a lot of functionality, lineage being one of them. It gives you data quality. But when you move to the cloud, it's harder because you use different tools and you're trying to optimize cost, performance, but we need to have to capture lineage. So what have our learnings been over the last 2.5 years? Good and bad. One, cloud is the way to go. So we are not regretting what we have been doing. We have to move to the cloud. That's the best way. It's also is a cultural shift because traditionally, as we have heard many other speakers say as well, we build these nice silos, we hold data around our own data. So we got 42 warehouses in investment banking because I won't trust someone else's data. I'll just do it myself because it's not documented. So the best way to do it is do it ourselves. So we are saying cloud helps us to smash these because we will not allow lift and shift. So this is the way to go. But when we looked at the industry, especially it was 18 months ago, things are changing now. The most common offering was the lake. You would see people talk about mesh, but when you actually open the cars, what the terms used for the tooling would always be a lake. Right? So you had data lake, open lake, whatever terms you use, they had lake in it. So you wonder, is it really just lake under a different name with a different name? So that's still there. So the primitives are available, right? Everything I've described so far, I'm sure you can point to a particular tool, technology, either open source or vendor that meets that requirement. So I just named some of them for data quality, access control, etc. You have them, but we have found no easy way of linking them together, making them work together seamlessly. Producers have to do work, consumers have to do work. So that's the challenge we are trying to solve. Industry standards are maturing. I think ONG and W3C are very good examples. They are doing a lot of work. We have a good team within UBS working extensively on some of these standards. We, of course, have been traditionally using the financial standards, FIX, FPML. We have been very active in that. We use that. So I think on the data passing, messaging side, we are pretty comfortable. But where we have challenges is in standards that define how the mesh should be built and sustained. Access control, I spoke about. It needs a lot more work. We need that integrated with the registry. So we are working with some of the vendors to see, with other tools that we could adopt and extend, but there is work that we'll be doing internally as well. And in a way that's helping because we are breaking the organizational barriers. Again, we heard that in a previous conversation. Once these applications are siloed and then, we are bound by these organizational boundaries. But I don't know whether it's agile or it's just the desperation to solve this problem. We have managed to break some of these walls down. So we do collaborate extensively across divisions. So some of the solutions we have, like the registry, is a shared service across the organization. And individual divisions have volunteered to do this for the rest of the organization. So it's a good example. I think in many ways Mesh has helped us to break some of these barriers. And then finally, the single pane of glass. We don't have that. So there's no one place. You can go to a marketplace, you can see what data products are, but you can't see any of the underlying processes that are building. So IT monitoring is still hard. So IT monitors have to be different. Business views are different. So our challenge remains, how do we bring it all together? So it's not all negative. I don't want to end the session on a negative note. We have produced a number of data products within the organization. It's been a great learning experience for many of us. I've loved it on my part. So if anything, I would say, instead of working on a problem that's already been solved, like warehouses or lakes for that matter, it's better to have this, because this I think is a very interesting area. And some of the technologies we have heard about in the last 3 days are all being used here by us, and I'm sure there are other organizations doing something similar. Some of this work will be open sourced. We are actively thinking of open sourcing some of the work we are doing, and we might have an opportunity to discuss that in future sessions. Thank you. Yeah.
We have some time for some questions. If anyone would like to ask anything, there's a mic going around.
Yep.
And if not, you can catch Heble here on the side if you've got any more. Oh, we've got a question there. Thank you.
Hey, so one of the issues that you were mentioning earlier was to determine what would consist in a good data product, right? So I'd just like to understand a bit better how you overcame this issue. Let's say you have operational teams that are running their applications and producing operational data. Were they the ones deciding that what was going to make a good data product, or do you have something a bit more central, like a data owner? So how did it work for you?
We haven't solved the problem of data owners owning the data and publishing in a common domain. That's our objective, but it's not been easy to do. But what we have done is we have identified what we call an authoritative source, one consumer who pretty much does this on behalf of others, and they have a model, a common model, that is then used to publish this data. So it comes in, so you could call, it's hybrid, essentially it is hybrid mesh. I didn't use the word hybrid because it looks like a lake. But that's the best way to solve the problem initially, because we otherwise have this huge problem of convincing every single producer to start adhering to this, and it's difficult. It's almost impossible initially, because everybody wants to see it working before they can adopt it. So we said, let's try it in one place. So that's the way we have done it currently.
Yeah, and just one additional question, if you don't mind. How are you keeping, say, data in sync? Let's say you have the data product, probably not going to be the same storage as the operational data, but you still need to keep it up to date, right? So you've been using something like eventing to maybe to keep the data up to date, or are you allowing some kind of lag, maybe like 1 hour, 2 hours a day, I don't know, using some batch process to feedback?
It's essentially eventual consistency. You have to depend on that. So we have something called an inventory control process, which checks. So source producers produce an inventory control file. It's a standard established pattern in the industry as well. So they produce an inventory control file, which is then checked by the consumer periodically. When I say periodically, it's typically end of the day. And then there's an exception flow if something is missing. It's expensive. It would have been much easier if the producer had produced their own data. We'll probably get there in a few years' time, but that's the slightly roundabout way of ensuring consistency, yes.
I think there's one more hand here at the front. Thanks, guys.
Thank you. So I have a question. I mean, how do we organizationally prevent multiple data meshes from being created?
That's an interesting question because we have grappled with it. We thought using different terminology would help, so we don't call it different meshes, we call it different nodes on the same mesh. I don't know if it helps, but essentially I think it's impossible to expect there's no duplication of data at all, if that's what you mean when you say multiple meshes. It means the same data may be existing in different meshes because they didn't talk to each other. It's possible. Much as governance, I mean, Zimmer calls it federated computational governance, but in some ways the governance has to be centralized to check this. Can you prevent it? Unlikely. I think the best way of doing it is to let these products be published in the mesh, see that in the marketplace, and then observe who is, so observability is another piece. I didn't talk much about observability, but it's important to see who is consuming the data and what it is being consumed for. And then you will immediately find out the ones that everybody wants and the data sets that nobody seems to want. For whatever reason, it might be because it's number 50 in the list and they have found something above that, the classic Google search response, or it could be because the data quality is poor or they're not quite sure who's produced it, etc. And then you need to have, like a garbage collection, you need to have a process of deprecating and retiring those data products. That's probably one way of weeding out some of these duplicates, but it's hard to, I think at the start we are saying let's produce it and then figure out how to clear out duplicates.